All right, now that we know a little bit more about two-way ANOVAs and the types of questions two-way ANOVAs can answer, let's go ahead and run a two-way ANOVA test through SASJump. So I have my mollusk data sheet, which has observation, the population from which the mollusks were pulled, the salinity, where we grew the mollusks, and also the shell length. And I've saved that as an XLS file, just like I have for the past videos. So what I want to do is open a data table, and again, I'll choose the mollusk data, and I'll go ahead and import that data into SASJump. So what's one of the important things that we do with our data sheet? The first thing we want to do is double check that SASJump has imported our data correctly. In other words, the data that we want to be nominal is nominal, and the data that we want to be continuous is continuous. So population is obviously a nominal data type, and as you can see here by our red bar, it's listed as nominal. Shell length is our continuous dependent variable, and as you can see, it is also listed as a continuous variable by the blue triangle. Now, something that SASJump tends to have a hard time with is determining whether a data type is nominal or continuous if it's a numeric value. So for salinity, we have values of 0 or values of 100. And as you can see, SASJump has considered that continuous. Well, we know that these are really just categories. A mollusk could either be grown in freshwater or in saline water. So we need to change this to a nominal data type. And to do that, we'll click on this triangle, go down to nominal, and as you can see, that changed it in the SASJump page. So now what do we need to do to actually run our test? Well, similar to what we did with the one-way ANOVA, we're going to go to Analysis. We're going to go to Fit Model. All right. So one thing we're sure of is that shell length is our dependent variable. So we can go ahead and put that over into our Y window. So in the last one-way ANOVA experiment, we put population into our model effects window. And that's fine, we can do that now, but keep in mind we also need to look at salinity, and we need to look at the interaction of these two variables. So I'm going to go ahead and remove these. And I'm going to show you an easy way to set up your model effects in the SASJump program. So what you want to do is select your two independent variables. You want to go down to Macros and click Full Factorial. And as you can see, we have the same model effects that we wrote out in the last video. We have population, salinity, and we have the interaction of population and salinity, population times salinity. So that's how we set up a two-way ANOVA in SASJump. It's really quite easy. And again, we want to make sure that we have effect leverage checked, and we will run the test. Okay, now this is a bit more complicated than the output we got for our one-way ANOVA, but it's still really simple to interpret. So whenever we're looking at a two-way ANOVA, the question we are really interested in is the interactive effect, and that is represented by this far right box over here. So this is population by salinity. But we do have our main effects of salinity and population in these other two blocks. And I told you in the last video that the main effects are equivalent of doing looking at that one variable and how it affects your dependent variable. And as you can see here, when I look at population in the two-way ANOVA, this main effect gives me the same means that I got from my one-way ANOVA. So that's just something to take note of. So similar to the one-way ANOVA, if we want to get our test statistic and we want to see our p-value associated with our test, we go down to Effect Tests. But as you can see here, this effects test is quite a bit larger than the one we got from the one-way ANOVA, because we have our population is one main effect, our salinity is another main effect, and our interaction of the two is a separate effect. Like I said, the one we are interested in for the two-way ANOVA is this population by salinity effect, and we see here that our p-value is less than 0.05. So that's wonderful. We know the p-value is less than 0.05, but what does that mean in terms of our results statement? So if we were going to write a results statement for this two-way ANOVA, we could say a couple things. We could say there was a statistically significant interaction between salinity and population. And we always want to be sure to put our F value and our P value. So the F value we would be looking at for the interaction statement is this bottom value, the one where we had our interaction. So our F ratio is 7.2696, and our P value equals 0.0007. And that tells us that we do see a difference among means. Now, is this a good way to state our results? I tend to say no. It doesn't explain any of the biology behind our question we're interested in. And if you'll notice, it doesn't even make mention of our dependent variable. So while that is a way to state it, and statistically it's a correct way to state it, it's not a very helpful one. Okay, so maybe we'll move to a different one. We could possibly say the salinity level differentially affects mollusk populations. Well, and again, we would put our F value and our P value in there. Okay, how does that sound? The salinity level differentially affects mollusk populations. Well, it tells us that depending on the population the mollusks lived in, salinity is affecting them differently. But we don't have any idea of what's being affected because we don't have our dependent variable in that statement. So I'm going to say no to that one as well. How about this one? The effect of salinity on mollusk shell size varies among the four populations. And again, I want to put my F value, which is approximately 7.27, and my P value, 0.0007. All right, I'm pretty happy with that results statement. The effect of salinity on mollusk shell size varies among the four populations. What that tells us is we're looking at mollusk shell size, which is our dependent variable. We're looking at the effect that salinity, one of our independent variables, has on the mollusk shell size and whether or not that effect varies among the four populations, another one of our independent variables. So I would be happy with that. However, I would like to put some more information about what we saw from the statistics into our results. So in order to do that, I am going to just erase this to give myself a bit more space. I do like the statement that I already put forth below. The effect of salinity on mollusk shell size varies among the four populations, but how does it vary? Well, if we go back to our jump output and we look on the far right at our interaction, remember in the one-way ANOVA, we did an a posteriori test, which told us exactly which ones of the means differed. Well, we're not going to do that for the two-way ANOVA because it gets a little bit complicated. But if I just look at these interactions of population and salinity level, I see that one really sticks out, and that's the Tillamook population that was subjected to 100 part per million salinity, and that one's quite a bit higher than the rest. So because of that, I may first say the effect of salinity on mollusk shell size varies among the four populations, and I'd give my F and P statistic. But I would also like to add a little bit more biological importance to that by saying the greatest shell size occurred when Tillamook, and I'm just going to abbreviate that for brevity, when Tillamook populations were placed in water with a salinity of 100 parts per million. All right. And what that does is gives me an overall statement of my results. But then it also says we saw something cool within those results that we'd like to point out, and that is that the Tillamook populations really responded positively to higher salinity levels, whereas those higher salinity levels did not affect other populations in that way. So that's how we would do our results statement for this two-way ANOVA. And again, remember, your results statement is not the same as your discussion statement or your conclusion statement. So in your discussion and conclusion, you then need to pose some reasons that you think that salinity is having differential effects on mollusks from those four populations, and why you think the Tillamook population did so well in high salinity water. So in the next video, I'm going to show you how to graph the two-way ANOVA results, which is a bit more complicated than one-way ANOVA, but it's still very doable. I'll see you then.